Students, continuation basics, that means question number 2. In this case, we are going to find out the total memory size from the following address lines. So in this one, we are going to see different address lines 14, 5, 22, 34 and 40 like this. So initially 14 address lines. 14 address lines is considered as a address lines. This can be divided into 4 plus 10. That means 2 power 4 is on 2 power 10. That means these are the powers. 4 plus 10 is the powers. So 2 power 10 is 2 power 4 into, that means, this is 16. 16 plus 2 power 10, that means 1k. So that 16k. This is 2 power 10 equal to k. 2 power 8 means 16. So that 16k memory, the size of the memory, we are going to find out the memory size. So from the 14 address lines, we are going to accessing 16k memory. So coming to the 5, that means 2 power 5. 2 power 5 means initially one address lines 2 power 1, that is equal to 2 bytes. 2 address lines 2 power 2, that means 4 bytes. 2 power 3 means 8 bytes. 2 power 4, 16 bytes. 2 power 5 address lines, 2 power 5 locations, that means 32 bytes. So in this case, 32 bytes is the memory size. Third case, 22. 22 means we are going to divide it, that means 2 plus 20. 2 power 20 means 2 power 20, 2 power 20, 2 power 2. 2 power 20 is represented as a 1 MB and 2 power 2 equal to 4. So that total, this is 1 MB, this is 4 megabytes. The memory size equal to 4 megabytes. Coming to the next one, 34. 34 plus 30. 30 means this is 2 power 30, 2 power 4. 30 means 1 GB. 1 GB, 2 power 4 equal to 16. That means 2 power 4, 16. This is 30 equal to 1 GB. That means 16 GB memory. That means with the help of 34 address lines, we are going to access 64 GB of the memory. So coming to the last case, that means 2 plus 40. 40 means 2 power 2, 2 power 40. 40 means 1 TB. 1 TB address, 2 power 2 means 4. That means 4 TB. The memory size equal to 4 TB memory. So with the help of 42 address lines, we are going to access 1 terabytes of the memory. Continuation question, here hexadecimal address from the following address lines. These are the address lines. So first address line 14, hexadecimal address. That means, so 14 address line, for example, if you are going to consider one memory, suppose if you have identified initial location and final location. So 14 address lines means initially we are going to expect, that means 14 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14, the next location is 0, 0, 0, 4, 5, 6, 7, 8, 9, 10, 11, 12, that means 13, 1. That means next 1, 0, all are zeros. 1, 1, all are zeros. 1, 0, 0. Subsequent locations like this. And finally, we are going to consider 14 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that initially we are going to find that means initial location starts from 14 zeros. Start from 14 zeros to 14 ones. So 14 ones means, so initially 14 zeros to 14 ones. Just finally we are going to find out the 4 bits. 4 ones means which represents in hexadecimal representation, that is equal to F. 4 ones, that means hexadecimal representation equal to F. And 4 ones, hexadecimal representation equal to 4 F. So remaining 2 ones are there. That means 4, 4, 4. 12 completed. Remaining 2 binary values are there. 1, 1 means that is equal to binary equivalent to 3. That means 3 FFFH. That is the final value equal to 3 FFFH. The hexadecimal address of this 12 hexadecimal address of this memory size is like this from the 14 address lines. So coming to the second case, same as it is, the memory size is like this, initially and final address. That means 5 zeros, 0, 0, 0, 0, 0. This address of the first location. 5 ones is the ending address of this memory location. That means 5 zeros and 5 ones. So just adding in the form of hexadecimal 4 bits. If 4 equal to F, remaining 1 is there. 1 means in this case also we have to consider 2 zeros in the above case. Here 1 is there for grouping purpose. Every time you need to 4 bits are there for hexadecimal representation, because 2 power 4 bits are needed to complete group, one group. So adding the left side equal to 3 zeros. The LSB side zeros is there is no value in this case. That means 0, 0, 1. So 1F. 1F is the 1FH is the hexadecimal value for 5 address lines. Coming to the 22, same as it is, 22 ones. The memory size initially and ending 0, 0, 0 like this. 22 width, 22 zeros and 22 ones. 1, 1, 1, 1. That means F. 1, 1, 1, 1. 4 ones. That means second F. 1, 1, 1, 1. So third F. Next 1, 1, 1, 1. So here totally 4 Fs. That means 4 into 4, 16 completed. 1, 1, 1, 1. So another F, means 20 is completed. So we have 22. 22 means remaining 2 is there. For grouping purpose, we are adding left side is 2 zeros. Means 3. The value equal to 3FF hexadecimal values. 3FFF like this. This is the address of the hexadecimal address of the 22. Like this, we are going to finding 3, 4 and 4, 2 also. That means initial location 34 zeros and final location 13 ones like this. Same as it is 42. Initial location is 42 zeros and for ending location 42 ones. So grouping 4 bits, then only you can get the exactly hexadecimal value of the this memory size.